Hi, this is Kenny Lee. Let's talk about solving some acceleration problems. So here's our basic equation for acceleration. Acceleration equals final velocity minus original velocity divided by time. And acceleration, for us, if we keep it in the standard SI units, is meters per second squared, or a way you kind of should think about it is meters per second, that this object is speeding up or slowing down so many meters per second every second of acceleration. VF stands for final velocity, VO stands for original velocity, and T is time. So let's look at our first question. We see this in car commercials all the time where they'll say, this car can go from 0 to 60 in so many seconds. So if we look at this question, we've got a car that goes from rest to 60 miles an hour in 3 seconds. And we want to know the acceleration. Well, first of all, sometimes we hide numbers with words. So a car goes from rest. So if it goes from rest, that means its original velocity is 0. If it comes to rest, that means the final velocity is 0. Or if it comes to a stop or comes to a halt. All those are ways to say that the final velocity is 0. So on this one, the original velocity is 0. Our final velocity, because that's what it gets up to, is 60 miles an hour. And then our time is 3 seconds. So we start off with the equation. A equals VF minus VO over T. Final velocity 60. Original 0. And we are going for 3 seconds. So my acceleration is 20. But the question is 20 what? Well, the top was in miles per hour. The bottom was in seconds. And we didn't convert this time because I didn't want to. I want to show you something. That means my unit is miles per hour per second. That means for every second of acceleration, on average, this car will speed up 20 miles per hour. So if it started off at 0, after 1 second it's doing 20 miles per hour. 2 seconds it's doing 40 miles per hour. 3 seconds it's doing 60 miles per hour because it gains 20 miles per hour every second. So in 4 seconds, if it's able to maintain that, it'll be going 80 miles an hour. 5 seconds it'll be going 100 miles an hour. If it maintains that, it gains 20 miles per hour every second of acceleration. So that unit means something that we can use. So let's take a look at another one. So here we got a toy going 5 meters per second and it accelerates to 20 meters per second. That's just a blob. In 8 seconds, what's the toy's acceleration? Well, again, we've got our original velocity is 5 meters per second. The final velocity is 20 meters per second. And our time is 8 seconds. And I want to know the acceleration. So A equals VF minus VO over T. So we've got a final velocity of 20, original of 5, and a time of 8 seconds. So we do the math. So let's just check this. 15 divided by 8 gives me 1.875. So we'll say 1.88. Now what would the unit be? Well, the top's in meters per second. The bottom's in seconds. So that's meters per second per second. So this toy will speed up 1.88 meters per second for every second of acceleration. The problem is we don't, well, math people freak out when you see a fraction inside of a fraction. They don't really like that. So it turns out we end up having to write it this way. 1.88 meters per second squared. Now if you think about it, second squared makes no sense whatsoever. You can buy something by the square foot or the square meter. That's how you buy flooring or something. But a square second, that's kind of hard to justify. But mathematically, this is right. But logically, we should think this way. It speeds up nearly 2 meters per second every second that it goes by. Let's say we've got a truck here Let's solve for something else besides acceleration. So we've got a truck going 3 meters per second, slows at a rate of 5 meters per second squared for 4 seconds. What's its final velocity? Okay, so we do have an original velocity and an acceleration. Acceleration is 5 meters per second squared. We'll come back to that. Original velocity was 30 meters per second, and our time was 4 seconds. But the problem says it slows. Well, if something's slowing down, that means it's losing speed. So it's losing speed, that means the acceleration is going to be negative. A deceleration is just an acceleration that's negative. You're losing speed instead of gaining it. So we're looking for VF. So A equals VF minus VO over T. Acceleration's minus 5 because we're losing that speed. VF we don't know. VO is 30. And our time is 4 seconds. So we start working the math. Add 30 to both sides. We get 10 meters per second is our final velocity. Now if we think about it, it makes sense. If you're losing 5 meters per second every second that goes by for 4 seconds, that means after 1 second you lost 5, 2 seconds you lost 10, 3 seconds you lost 15, 4 seconds you've lost 20 meters per second. Well, if you start off with 30 and you lost 20 meters per second, you should be down to 10. So that's a way that you can think about it and check your answer. Last one. We've got a student traveling at 27 meters per second. The student slows to a rate of 15 meters per second. If the student decelerates at 4 meters per second squared, how long does this take? So on this one, we're actually looking for time because we've got an original velocity of 27 meters per second, a final velocity, because this is what it goes to, of 15 meters per second, decelerates at 4 meters per second squared, so that acceleration is 4 meters per second squared, but since he's losing speed, he's decelerating, that makes that negative, and we're looking for time. So A equals VF minus VO over T. Let's start plugging in our numbers. That's minus 4. VF is 15. VO is 27. We got to find time. This is a good time for a little math trick that I call the super secret math trick. Super secret math trick is if you're solving for this denominator, just swap these two. The T will come out and the negative 4 will take its place. So let's go ahead and do the math. So we'll bring this in again. So 15 minus 27, negative 12. So we get negative 12 over a negative 4. So that means our time is going to be 3 seconds. Here's another clue. If you happen to have not noticed that and did this problem, well, that negative sign wouldn't have been there. You would have got a negative time. You can't get a negative time because that means whatever you did actually caused you to go backwards in time. That doesn't happen. So if that ever happens, you ever get a negative time, look to see if you miss something like this, where that makes that number negative, but it doesn't show up negative in the statement. But it needs to be negative in when you do the math. Okay? Thank you very much, and I'll talk to you in another video.